Have you ever wondered how an AI actually thinks? Or maybe more to the point, how it remembers what you're talking about from 1 minute to the next? Well, it turns out that memory, it's one of the single biggest challenges in AI development today. So let's dive into what's really going on here.
So you see these huge numbers thrown around, right? Like Google's Gemini 3, with a context window of a whopping 2 million tokens. Now, what's a token? It's basically a piece of a word, kind of like the building block of language for an AI. And 2 million of them, that is a ton of information. We're talking thousands and thousands of pages of text.
But here's the twist. Even a memory that can hold like 15 entire novels worth of information, it fills up. And it fills up shockingly fast, especially when you're working on real, complex projects. It's not nearly as big as it sounds. So, what's going on?
Okay, to really get this, we need a totally new mental model. We gotta stop thinking about an AI's memory like it's this huge, endless library. Instead, we need to think of it as a really specific kind of short-term working memory.
And here's the perfect analogy for it. Think of the context window as the RAM in your computer. It's super fast, it's absolutely essential for whatever you're doing right now, but it has a very strict size limit. Once it's full, it's full. Something has to go.
So here's the bottom line. The context window is the maximum amount of stuff an AI can process at once. It's literally everything the AI can see in a single moment. That includes your instructions, the files you give it, your whole conversation history, and it even has to save room for its own answer. It all has to fit.
And if we look at the landscape today, you've got models like OpenAI's GPT 5.2 or Anthropic's Claude Opus 4.5, which can handle something like 500 or 600 pages. Then you have the big one, Google's Gemini 3 Pro, which is this outlier with a massive 5,000 page capacity. But remember, even with 5,000 pages, it's still facing the exact same fundamental problem. It's a hard limit.
So that leads to the obvious question, right? If this memory is so valuable, what in the world is filling this massive space up so quickly?
Well, it's a whole bunch of things, and they add up fast. First, you've got the system prompt. That can be thousands of tokens right there. Then you add the project specs, the entire history of your chat, and then, here's the big one, all the relevant code files. That can be tens, even hundreds of thousands of tokens. And don't forget, the model still needs room for its own response. Everything is fighting for that same limited RAM.
And this brings us to what you could call the zero-sum reality of AI memory. It's this constant battle for space, where every single piece of information you add means something else might have to go.
It's a trade-off, plain and simple. Think about it. Every single token you use for your chat history, that's a token you can't use to give the AI a critical piece of code. If you have a long, rambling conversation, that history is eating up precious memory that could have been used for something much more important. It really is a zero-sum game.
And you might be thinking, well, why not just make the window bigger? The thing is, that doesn't solve everything. In fact, huge context windows come with their own headaches. They cost more money to run, they can be way slower, and models can actually suffer from this weird lost-in-the-middle problem, where they kind of forget or ignore information that's buried in the center of a giant wall of text.
So if the problem is this limited, competitive working memory, what's the solution? Well, it's not just sitting around and waiting for bigger models to come out. It's about developing a new, absolutely essential skill for this AI era, and that skill is called context engineering.
So what is context engineering? It's basically the skill of deciding what goes into the context window, and, just as importantly, what stays out, all to maximize the quality of the answer you get. You become the AI's memory manager.
Okay, so how do you actually do it? It really boils down to 3 key strategies. Number 1 is smart selection. That means only picking the files that are actually relevant. 2 is compression, learning to say what you mean with fewer words. And 3rd is progressive loading, giving the AI information piece by piece, as it needs it, instead of dumping everything on it at once. And look, these aren't just abstract theories. You can put this into practice right now. For example, you can use AI-First IDEs that help you with smart code selection. You can write really concise, clear specs to compress your intent. And hey, don't be afraid to just start a fresh conversation for a new topic to clear its memory. A great tip is to maintain a simple project_context.md file that sums everything up. Ultimately, all of this means we need to fundamentally shift how we think about working with AI. It's not just a tool, it's a collaborator. And that requires a totally new mental model.
So the old model was thinking of the AI as a knowledgeable colleague who just remembers everything. We got to ditch that. The new model, the one that actually works, is to think of the AI as a brilliant, world-class expert who has complete and total amnesia. Every single time you talk to it, you are starting from scratch.
And that really brings us to the most crucial takeaway of all. Because you're working with this brilliant expert with amnesia, you are responsible for the briefing. Every single session, you have to provide all the relevant context, and you have to do it concisely to make the absolute best use of that limited working memory.
So I'll leave you with a question to really put this into practice. Think about a project you're working on right now. If you had to brief that brilliant expert with amnesia, but you only had enough space for 3 files to give them all the context they need to get started, which 3 files would you pick? Answering that question, well, that's your first step to becoming a great context engineer.